Hi everyone. In this video, we are going to see the predicate calculus. So first of all, what is predicate calculus? The logic based on predicate is called predicate calculus. For that, we need to know what is quantifier. So the word indicates, the quantifier means the word indicates, it specifies some quantity. It denotes some quantity. So for us, we have all, for some example or some few, these are the example for quantifier. So that next we are going to see the types of quantifier. We have two types of quantifier, that is universal quantifier. Another one is existential quantifier. Universal quantifier is denoted by for all. Universal quantifier is denoted by for all. The symbol name is also called for all. Existential quantifier is denoted by there exists. The symbol is called there exists. So like theory of inferences, here also we have some four rules. So anyway, for doing this derivation, we have to know the theory of inferences rules and all the method. So everything is same for doing this predicate or calculus also. And also please, before going to watch this video, once you check that theory of inferences video thoroughly, then go for this. This would be very useful for you for doing all those problems. Yes, let's start. First of all, first rule, universal specification. What is this universal specification is called? So here they given, actually here they given, it is the generalization. From this, this symbol is called for all. You mean universal generalization. From this, we are going to make a specification. That's why this is called universal specification. Instead of for all x, and p of x, I am going to denote this for all x and this x. You have to denote y. So that is called p of y. So this is called universal specification. So next, universal generalization. What is universal generalization? So they may give universal specification. From this universal specification, now we are going to change it to universal generalization. Universal generalization means you have to use for all symbol. Next, existential specification. For existential specification, they given generalization format. This symbol is called existential generalization. From this, we are going to change the specification is p of y. So similarly, existential generalization, this is specification format. From that, we are going to do the generalization for existential. For that symbol, you have to use there exists. And now we are going to check what is negation law. So it is negation law is totally different from the previous proportions, that is previous topic, that is negation law. So now we are going to take negation of this statement. So negation of there exists x p of x. What we need to do, for all is changed, there exists is changed by for all, and that negation you have to write it with the premises, that is there exists means you have to change for all x negation p of x. So similarly, for this negation statement also, you have to change negation of for all is there exists x and negation p of x. This is the format of doing negation. And now we are going to see some problem for predicate calculus. Write it in a symbolic form. Something is green, everything is green, nothing is green, something is not green. So everything is based on green. So that is why what I am going to do, let g of x is equal to x is green. Okay, g of x, that x is green. Okay, we are taking g of x, that value of x is green. So first one, something which means it's very less quantity, something. So that's why very less quantity means we have to use there exists x. Here we have taken g is nothing but green color. So g of x. Second one, everything. Everything means entire thing. So the everything means entire thing. So you have to use for all x g of x. Entire thing for all x g of x. And third, nothing is green. And third is nothing is green. So nothing means it is a negation. So all the things are not green. So that's why for all x, all the things are not green. So this is important. Negation g of x. So what is the thing? Nothing is green. So nothing is green means for all x, everything but this is not green, not green. So that's why nothing is green. Okay. Next, something is green. Something is also negation statement. Something is green. So that's why we are going to apply there exists x negation g of x. There exists x negation g of x. Got it? Something is not green. So not means you have to use negation g of x. Yes. Let's see the next problem. Write in a symbolic form. All men are giants. All men are giants. No men are giants. Some men are giants. Some men are not giants. The same way we are going to see. Let this is men. So that's why you can take any symbol. But if it is the first letter means that is somewhat very good. So I'm taking m of x for men. So x is men. X is men or man. Okay. Next, I'm going to take g of x. That is x is giant. Let's see the symbolic form for all men are giant. All means all the things. So that's why we have to write for all x, all men. Men means m of x are giant. So if g of x, this is the format of framing the two condition symbolic form. So next, no men are giant. No men are giant. So that's why we have to use negation. No men. So for all x, because here everything consider, but it's a negation. So m of x negation g of x, because no men are giant. So that's why here you have to apply negation. Okay. Next is C. Some men are giants. Some men means there exists x are giant. M of x, g of x. Next, some men are not giants. So here itself they given not. So we have to use m of x negation g of x. Okay, not giant. So that's why negation g of x. So the next symbolic form, all cats are animals. So we can say for all x, cat means c of x I'm taking, animal means I'm taking a of x. So similarly, some cats, you mean there exists x, c of x and are black. So that's why and b of x. Okay, similarly, if you find free time, try to do this problems also. So next, negate. Every student in the class is intelligent. You have to write a negation of this statement. So for that, every student in the class is intelligent. So every student mean negation is no student in the class is intelligent. So this is the answer. Next, we are going to see one problem, how to do the predicate calculus. Verify the validity of the following argument. Lions are dangerous animals. There are lions. Therefore, there are dangerous animals. First of all, before going to solve this problem, we need a symbolized form. So that's why I have written here symbolized form. Yes, let's start this problem. So lion, I'm going to take L of x. Here x is lion. And dangerous, that's why I'm going to take d of x. Here I'm consider x is dangerous. Okay. So let's form a premises for this. The premises are, so the given word, lions are dangerous animals. So all the lions are dangerous. So that's why for all x, L of x, all dangerous animals. So that's why it is d of x, L of x, d of x, dangerous animals. And therefore there are dangerous animal. And also they given there are, see the thing, there are lions. So that time we have to frame one more premises, that is there are lions. There exists x, lions, L of x. That's it. There are lions. That's it. So what is the proof for this? For the conclusion, therefore there are dangerous animals. Therefore there are dangerous animals. So there exists x, d of x. So this is the conclusion. So this is your conclusion. So you have to prove this. Your derivation part, finally we need to prove the conclusion is the dangerous animals, d of x. So for how to solve your inferences the theory, the same format only we have to solve this also. Yes, first let us consider step number 1. So the rules are same. Whatever the premises you are going to introduce, that is called rule P. Whenever you apply the formula, that is called rule T. So everything you know. So now I'm going to introduce the premises for all x. The first premises, lions are dangerous animal, right? The first premises I'm taking, this is called rule P. So whenever you introduce the premises from the derivation part, you have to write it is rule P. Second one, if you apply the formula, you have to write rule T anyway. So I'm going to do the, for all means it is universal, right? So I'm going to do universal specification here. This is in the form of, so now it is universal generalization. Now I'm going to do universal specification. I'm going to convert. So that is why L of y if D of y. Here I converted, this is rule T, but what I did, universal specification, I did universal specification of 1. Rule T of 1, universal specification. Third one, what I am going to do, I am going to introduce the another premises, there exists x, L of x. So this is called rule P. Whenever you introduce the premises, that is called rule P, right? And fourth one, I am going to do the generalization. First of all, you have to identify what is this. Actually, this is nothing but existential generalization. Now you are going to do existential specification, L of y, which is nothing but rule T of 3 existential specification. Rule T of 3 existential specification. Fifth one, what I am going to do, fifth one, I am going to use the modus ponens rule for these two things. I am going to use modus ponens, then Ly getting cancelled and remaining we are getting D of y. So this is called rule T of 2, 4. So here what we did, modus ponens. After that, finally our solution must be lions are dangerous animal. So here we have dy, it is nothing but specification. Now we are going to do the generalization format. For also we need existential generalization. Therefore, there exists x d of x, because we need the solution existential generalization of 5. Existential generalization of 5. So this is the format how to solve. Hence the argument is valid. Hence the argument is valid. So what are the see, for inferences theory, we have direct method, indirect method, rule P, rule CP, and are inconsistent, consistent, everything here also applicable. So that's why before going to watch this video, kindly check the inferences theory video followed by this. Okay. So next problem I have given here. Prove that, so this is the problem. Prove that for all x, P of x or Q of x, which implies this is only one premises, and final solution also they given, but they given indirect method. Indirect method means we have to introduce one new premises. That new premises must be negation of conclusion. That new premises must be negation of conclusion. The same thing I have did. I am taking negation of this conclusion. So we have to add this as an additional premises. So we have two premises here. Step number 1, introduce the negation premises, that is rule P, negated conclusion first I am introducing. After that, taking the negation law. So for all means it will be converted by there exists as per negation law and negation P of x. So similarly, there exists, you have to convert for all, and you have to write negation. This is called negation rule. Then what I am going to do, I am taking the simplification of this. And means, so what is the simplification? P and Q means we can write P separately and Q separately. It's what simplification rule in inferences theory. So the same thing we have did here, 3 and 4. Then we are taking these two things, everything. It is this is the format of like existential generalization. Now you have to do you have to do existential specification. Similarly, this one you have to do universal specification. So indirect method means we have to introduce new premises. That new premises must be negation of conclusion. Finally, we need to say false. So finally, what we need to say? False. Yes. So next, what I am going to do here, I am going to do conjunction. What is conjunction? If P comma Q is there, means we can write P and Q. That is called conjunction. The same thing we are doing for 5 and 6 here. Then you are taking the negation out. If you take negation out, this is called rule T for De Morgan's law. Then what we are doing here, I'm going to do like generally, I'm going to introduce the other premises. This okay, the first premises in the question, first premises, and this is your universal generalization. From this, you have to do universal specification. After that, right, that is P and negation P is false by complement law. The same thing we are doing here. So entire thing you just consider P. So that is negation P and P is called false. Anyway, the indirect method means finally we need to say false. So anyway, we have proved for this also. So this is a format of solving this type of predicate calculus. And also one more thing I want to introduce by the contradiction method. Prove that root 2 is irrational by giving a proof by contradiction. So what we need to do, for that we have to take a contradiction. Here they given it is irrational. So what we need to take, the proportion must be rational. Okay, opposite. Negation P is true. Suppose negation P is true. Negation P means it is a rational. So what is rational number? How to denote rational number? A by B, where B is not equal to 0 and there is no common factor. So that's why I am introducing this. And root 2 is nothing but A by B. And taking square on both sides, you are getting 2 is equal to A square by B square. And cross multiplying this, 2B square will come. This means 2b square. What it means, it is this is nothing but a square is nothing but even, which implies a is also even. Furthermore, what we are going to take, if a is equal to 2c for some integer, okay, because it is even, and 2b square is nothing but 2a square, that is 4c square. And what is the value of b square is also even. This means that b square is even, and hence b is even. It has been shown. Negation P implies root 2 A by B. So this B have no common factor, and 2 divides A and B. So this is somewhat totally contradiction. If 2 divides A and B means it have some common factor. Since we have to show that negation P implies both R and negation R. So just we are saying one extra promotion where R is extra proportion, where R is the statement that A and B are integers with no common factors. Hence negation P, whatever the contradiction be taken, that negation P is false. So therefore, finally we are saying root 2 is irrational and it is true. Okay, so this is the last topic in unit your this is the last topic for unit 1 syllabus in Anna University syllabus. If you like this video, please consider support me and hit the bell icon and subscribe to this channel. Thank you. Bye.